Hello everyone. I'm going to do some exercise solving improper definite integrals, and by doing these I'm going to select some integrand that all the technique that we have learned so far I can apply. The first one is going to become x squared e to the power of negative x dx. That's my integrand. 0 is part of my domain, but that infinity make it an improper integral. Remember, this one an algebraic function, this is an exponential function, and that's the part of the product rules. Remember, you might have x squared times e to the power of negative x, and they said give me the derivative of it. You copy the first times derivative of a second, plus copy the second derivative of a first. That's part of it. That's one of those, either f prime, the derivative of first times the second, or the derivative of a second times the first. Therefore, when you do integration by part, you undo one of those pieces. In here, I have to do integration by part and use Liate to determine your u. And in this case, if you remember, I'm going to use tabular method to make it very quick. On tabular method, your u is x squared, and your dv is e to the power of negatives dx. And this one become your du, which is 2x dx. But that du become a u for the next one, and it become a 2. And that's the d2 dx. But I don't write the dx because it become a u for the next one. And that's becomes 0 du, and you stop. Therefore, this is dv, the integral of a dv, which is the v is negative e to the power of negative x. But I do need a dx in here because that's become a v for the next one, and that's become e to the power of a negative x. And this is again your v, but it is become a dv for the next one, which is the next v is negative e to the power of negative x. And your answer for this problem is pretty much that one. And see, 0 times anything is 0. You stop here. And integration by part is uv minus v du plus uv minus v du. Therefore, your answer is going to become negative x squared e to the power of negative x minus 2x e to the power of negative x and minus 2e to the power of negative x. And this has to go from 0 to infinity, but I cannot put infinity. I put a, and I'm going to take the limit as a approaches infinity. First, I'm going to evaluate that definite integral, but since I have a negative exponent, I'm going to move it downstairs to make my life a little bit easier, because I know anything divided by infinity make it 0. And then I go from 0 to a, that become negative a squared over e to the power of a minus 2a e to the power of a minus 2 e to the power of a. That's your positive quantity, which is f of b minus f of a is 0 over 1 minus 0 over 1 and minus 2 over 1. Because e to the power of 0 is 1, and this answer is going to become 2. Therefore, I know the second one converges, but I don't know about the first one. Therefore, I have to take the limit of that one as a approaches infinity, and in this case, it becomes infinity over infinity, infinity over infinity, and that becomes 2 over infinity. That piece is 0. But infinity over infinity become a L'Hopital rules, and you have to apply the L'Hopital rules is 2a over e to the power of a. That's again infinity over infinity. I have to apply L'Hopital rules is negative 2a is to the power of a, and that's normal L'Hopital rules, because when I take the limit, see, I took a L'Hopital rules here, I took a L'Hopital rules. Then I'm going to take the limit as a approaches infinity, and that become negative 2 to the power of infinity. That's make it a 0. Here, it become infinity over infinity. I have to apply the L'Hopital rules. And when I take the derivative, when I take negative 2 over e to the power of infinity, it become negative 2 to the power of infinity, and that's make it a 0. Therefore, and this become e to the power of infinity, that become a 0. Therefore, your answer is only 2. And remember, is approaches to, is not a 2, is approaches to, and therefore this is going to become converge. The next one, I'm going to use a function of e to the power of negative x cosine of x. In here, 0 is no issue, but when I put infinity here, that's make it improper. And in here, I have no other option to make integration by part. Unlike this problem, that when I take the u, which is a polynomial, and take its derivative several times, is lead to the 0, in no matter which one you pick you never end up with a 0. Therefore, it doesn't matter which one you get u or du right here, because they're going to repeat itself. Therefore, in this one, because it repeats, you must stop the process when the trig function repeated itself. Therefore, I'm going to make my u to become cosine x, my du again become a negative sine x, and derivative of sine is a cosine. And remember, the cosine is stop. The cosine repeats, you stop. It doesn't matter if it's positive or negative, you stop. Remember, you put u, v. That's a positive, that's a negative, that's a positive. Remember, these signs are for the derivative, but these are for the integration by part sign. Your dv is e to the power of negative x dx. Your v is negative e to the power of negative x. Your v is e to the power of negative x. But you stop right there. Your answer becomes this, and the integral of the last column. Okay, therefore in here I'm going to have negative e to the power of negative x cosine x. Negative times negative is a positive, plus e to the power of negative x sine of x. And in here I have negative, and it becomes cosine x e to the power of negative x dx. Remember, this one repeats itself. Therefore, I'm going to move this one to the other side. It becomes 2 of them. Therefore, the integral of 0 to the power of a, as take the limit as a approaches infinity of e to the power of negative x cosine x become equal to the limit of a approaches infinity of cosine x over e to the power of x and negative plus sine x over e to the power of x, all divided by 2, because you took the other one to that side and you divided by 2, and you go from 0 to a. Therefore, here you have cosine of a over 2e to the power of a. Therefore, here you have sine of a over 2e to the power of a. That's your f of b minus f of a. Cosine of 0 is 1. E to the power of 0 is 1. Therefore, you have negative 1/2. I'm sorry. Sine of 0 is 0. The other part is 0. That part is 1/2. Let's talk about this one. When I take the limit as a approaches infinity. When a approaches infinity, I don't know. When a approaches infinity, this approaches negative 1 and 1. Some student going to say, well, that's going to be a number. That's going to become, no, that's cosine of infinity. Cosine of infinity is something between negative 1 and 1. And this is e to the power of infinity is infinity. A number of an infinity is 0. Yes, you can make that conjecture, but it's not a correct one. But I do know cosine of a is between 1 and a negative 1. I'm going to use the sandwich method, and I'm going to divide it e to the power of a, e to the power of a, e to the power of a. I'm going to take the limit of that one as a approaches infinity. I'm going to take the limit of that one as a approaches infinity. I'm going to take the limit of that one as a approaches infinity. This becomes negative 1 over infinity is 0. The limit of a approaches infinity of cosine of a over e to the power of a. I don't know what it is. And the other side, when I take the limit is 0, give me a number which is less than or equal to 0 and greater than or equal to 0, and that number is 0. Therefore, this is a 0. Same thing you can do with this one, that's the 0. And the answer is 1/2. And you're going to say, yes, this converges to 1/2. It does not diverge, it converges. The next one, I'm going to go from 2 to the power of infinity, a 1 over x cubed dx. In this case, I'm going to use P series. And P series, I'm going to try to find area under the curve from 2 to infinity. Remember, we said from 1 to infinity. Well, if 1 to infinity by the P series, because P is greater than 1, is converges, I bet you from 2, it's going to become less area under the curve. Therefore, this also by the P series converge. But what happens if I have 0 to 1? 1 over x squared dx. This graph is right here, and 0 is here, 1 here, and I want to know that one. You cannot do P series. P series is from 1 to infinity, but you might go from 5 to infinity or 20 to infinity. And remember, if 1 to infinity converge, I bet you 10 to infinity is also converges, because 1 to infinity is much, much bigger. But if 1 to infinity diverges, I do not guarantee that 2 to infinity diverges. In here, I cannot use a P series, but I cannot have a 0 here. I can have 1. I'll make this one a, and 0 is here, 1 is here. I'm approaching the smallest number possible in the 0, and I'm going to take the limit as a approaches 0 from the right. Therefore, that one is become x to the power of -2 from a to 1 dx, and that's become x to the power of -2 plus 1 over -2 plus 1 from a to 1, and that's become -1 over x from a to 1, and that become -1 over 1 minus -1 over a. Right now, I'm going to take the limit as a approaches 0. I know this piece is going to become -1. This piece is plus 1 over a. But what is 1 over 0? Undefined. Therefore, that area diverges. Next, I'm going to do 1, maybe 0, to maybe e, natural log of x squared dx. Okay, this is a logarithmic function, and this is different from natural log of x as a quantity squared. This is only the x that has a power of 2. Therefore, if this one was this, you couldn't move the 2 back here. That's a quantity squared. But this is the power, that's the power. I can write this one as 2 natural log of x from 0 to e dx. And in this case, unfortunately, natural log of 0 is undefined. That's the improper one. I'm going to take the limit as a approaches 0 from the right, and that would become a to e. I'm going to put the 2 outside, natural log of x dx. I really don't know any function that is derivative is natural log. Therefore, every time you have an integrand that you cannot take is antiderivative, but it is easier to take its derivative, use integration by part. Therefore, in here, my u as a liate is a natural log of x. Whatever left is your dv. The du is 1 over x dx. See how I could differentiate it very easily? But your v is x. Right now, your answer is x, natural log of x, minus a v du, which is x over x dx. And that answer is an x natural log of x minus x from a to e. E natural log of e. Natural log of e is 1. This is e. Minus an e. The first piece is 0. Minus the second piece is a natural log of a minus a. Okay, that a is from the formula, and that's become like that. Therefore, you have the limit of a approaches 0 from the right of a minus a natural log of a. Natural log of 0 is undefined. This one diverges. Next, I'm going to go 3 to infinity. I'm going to do this one very quick of 1 over x minus 1 to the power of 4 dx. That is improper. Remember, when I expand that one, you're going to have x to the power of 4 plus a whole bunch of other terms. This is a leading variable. As it goes to infinity, who cares about the rest? The leading variable is the most important part. The leading variable by the p-series, this is greater than 1, and if from 1 to infinity, a 1 over x to the power of 4 dx, since this is much, much bigger area under the curve of that one, and it converges. If this converges, and which is the area under the curve bigger than that one, I bet you this is the smaller than this one. Therefore, that will converge. What number does it converge? I have no clue. They asked me to find if it's a convergence or divergence. Therefore, I'm not going to bother my brain to solve the problem. I just tell them, you ask me, and I'm saying it's convergence. Next, I'm going to put 4 to infinity of square root of x squared minus 16 over x squared dx. You know I can have 4 here. I have no issue. But undefined quantity make it improper. In here, these are both algebra function. I don't want to do integration by part. I don't see it as an inverse trig function. The best thing is here, I see this one as a cs squared minus a squared is going to be a trig substitution, and change the algebra to trig and find the antiderivative of a trig function, then change it back to algebra using that right triangle. I'm going to pick that angle. I'm going to make the hypotenuse a c. I'm going to put a 4 here. Don't put the 4 here because the x has to be on the top, and that become a cosecant. But if I put it right here, it make it a secant. Therefore, what you have on the numerator is this. And what trig function is tied to this one? Well, I can say sine is this over that. And instead of that x, put sine this over this and write another x in here and make this one a sine. Or I can put this over this as a tangent. These are all your option. Nobody can tell you which method to use as long as you are doing the right process. This is over 4, but I put the 4 here. Therefore, I put on my numerator 4 tangent of alpha. But instead of a x squared, I'm going to go in here and solve for a helping equation. And that helping equation is secant of alpha equal to x over 4. And my x squared is 16 secant square of alpha. And my dx is 16 secant of alpha, tangent of alpha, d alpha. And if one day I needed to solve for alpha, your alpha is arc secant of x over 4. Okay, let's go to the problem. The top is a tangent. It is 4 tangent, not a tangent. The bottom is x squared, and x squared is 4 16 secant square of alpha. My dx is 16 secant of alpha, tangent of alpha, d alpha. Thank God that 16 and 16 is gone. That tangent and one of these tangent is gone. That's tangent square over a secant with a 4 right here. 4 What is tangent square? Tangent square is sine square of alpha over cosine square of alpha. The bottom is a secant. What is the reciprocal of a secant? 1 over secant is the cosine. What happened to one of the cosine? Is gone. How many sine you have on the top? You have 2 sine. Sine over a cosine is cotangent. And you have another, here I cannot do anything. I'm sorry. You have sine squared, which is 1 minus cosine squared over cosine alpha. In here, I have to decompose it. I couldn't write here cotangent times sine. Cotangent as a sine doesn't do anything for me. Here, I'm going to write 1 over cosine, which is the secant of alpha, all by itself, and cosine squared over a cosine is the cosine of alpha, d alpha, and both of these are integrable. And I'm going to do, the secant is the natural log of quantity secant of alpha plus tangent of alpha. The inverse of the integral of cosine is a sine. This is a negative sine, but I gave you an algebraic function, not a trick. I go to this triangle and I said this is a natural log of a secant, which is x over 4, and the tangent is the square root of x squared minus 16 over 4, and the sine is the square root of x squared minus 16 over x. All of these is from 4 to infinity. But what was the infinity? Was a. And I take the limit as a approaches infinity. Okay. Let's talk. What is infinity squared minus 16 is infinity. What is the square root of infinity is still a large number. A large number divided by 4 is a large number. What is infinity over 4? Infinity. What is the natural log of infinity? X is infinity. The y is also infinity. Therefore, I know this one diverges. I'm not going to bother mind with the other piece, and I'm going to say diverge. I really am a little bit tired, but I want to make sure to check my work. If I did it right, then if I didn't do it right, I'm going to come back and find my mistake. I go right here and I put the square root of x squared minus 16 divided by x squared. Okay, I'm going to go to math number 9. I can put 4, but I cannot put infinity. I'll put 100. And I'm going to put a variable y1 and a yx. I'm going to put 100. I'm going to say what is area under the curve. Not bad. A lot of rectangle. 2.91. Maybe I change this one to 1,000. If this becomes 2.92, it's going to converge. But if you go beyond the 2.9 to 9.3, then I have an issue. Because it is very last. That's going to diverge. But what happens if I put right here a couple more? Probably calculator are going to say, I'm sorry, I don't have enough memory, I don't have a brain. And I'm hoping it give us the answer. And probably this is going to be more than 5, 9. Therefore, my divergence is right. If you don't believe it, I can go to my window and I said go from 0 to 10. And my y value, because the positive number, I go from -2. This become, that graph is right there. Therefore, I don't need a lot of 10. Therefore, I go to my window and I'm going to say from -1 maybe to 1 with a scale of 0.1. Let me see what it said. Is right there. But what happened if I go right here and to make it 100 with a scale of 10? Let me put this one 0.5 and make this one a -0.1. Let me see what happened. See, that's my graph. And see, it approaches and approaches and approaches. Does it ever become 0? No, and the area under the curve is getting larger and larger. If that graph was falling toward X much, much faster. Let me give you an example. See, when you have 1 over X, and whenever you graph it, that graph of 1 over X does not fall. I don't know what did I do with the calculator. Let me see, what did I do? 1 over X, and my window is, I don't need a -X right here. And let me see why that's my graph. See, it does not fall toward, you think it is, but it's not really is, because if I go right here and go say 0 to 1 only with a 0.1, you see, it does not fall as fast as this function, which is 1 divided by x squared. Look at how fast 1 over x squared. That's the reason the P-series said if it's 1 or less, it diverges, because if I put right here 1 divided by the square root of x, that won't even fall toward x slower than 1 over x. Therefore, this is where your wall is. If this one is diverged, the rest of this diverge, but below that one is going to converge. Therefore, the graph has to fall toward the x-axis a lot fast in order to converge. Thank you very much. That was the end of the technique of integration and improper integrals. I will lead on to parametric functions and maybe touch about conic sections and the polar coordinate. Thank you.